Now we've been coming right back to the article. You've done your research, you've selected the journal you wanted, you've read the guide to authors of that particular journal. It tells you all sorts of things. Then it's a question to think, okay, now it's time to write the article. Everyone has agreed, everything's there, and then you start thinking, who's going to write the structure and so on, who's going to polish it. There's all those things you think about. It's falling apart here. So here we've got a typical structure of a research article with a fish. Why a fish? Why not? A picture. I wanted a picture I could describe later, you'd remember. We think in pictures, we're human beings. It has to have some relevance, of course. And the relevance is, well, this is a typical structure of a research article. Title, abstracts, keywords, then you've got introduction, methods, results, discussions, conclusion, acknowledgements, references, and so on. So here is the head of the article. Here's the middle, here's the tail. So here's the head, here's the body, here's the tail. So that's how you can see why I had a fish, to find something which had a head, a body, and a tail, the layout. Okay. The title, abstracts, and keywords can be seen anywhere in the world. You don't have to be inside the IP address of the university. You can be in downtown in some coffee restaurant and just go and find these things in PubMed or in Science Direct or in Springer Link or anything. And then the main text is, as normal sequence is laid out, it does vary a bit from journal to journal. If a journal tells you how it wants it, use that, because that journal has decided specifically to tell you the layout. If they haven't told you the layout, this is a useful way of laying it out. This is the logical line. You know, here's what we did, here's what we found, here's what things going on. This doesn't work for things like reviews, microarticles, social sciences, of course, much more discussion, much less results, but this is a good idea, a good basis. And it is a challenge to get it right. Now, that's how you lay out the article. How do you write the article? Do you start with a blank piece of paper and start with a title? No. That is hard work. Think of it as building a wall. This is your timeline here. So the figures in the tables is your data. And then, based on that, it's your comfort zone, basically. You then describe the methods you used, then some results you're describing, then you discuss those results, then you write your conclusion, and then you write your introduction. Then you write the title, abstracts, and keywords. So as a timeline, you're building a wall. Once you've built the wall, then you lay it out, fish style. But you build the wall first. It's less likely to have sort of brain freeze or writer's cramp or anything else. And then it's far easier to actually to get going. And now I'm going to just briefly go through some aspects of the components of an article using the fish style. See, fish, wall, you see it, pictures. Title. As short as it can be, but still telling what's going on. Now, things like newspapers, magazines, actually, they have professional staff writing headlines. We don't have that luxury with scientists. We do it ourselves. And so what you can do, and also, unfortunately, many referees will not give guidance on your title of your article. They see it as outside of their remit, which is sad, because they should do, but they don't. We always teach it in the reviewer workshop, but they should actually help you with your review, title of your review. But the reality is, they don't. So, you are on your own. So you and your co-authors work out what should it be. And so it's in draft. You're going to do 4, 5, 6 versions of the article as in draft form. So start with what you think is about right. Say, okay. So it has to be identifying the main aspect of the paper, the core of the paper. You've got to get somehow your article to be attractive to read. Imagine you're this reader. You just downloaded a whole bunch of articles from PubMed. There's all the titles. And you're skimming through them, and one leaps out at you. What did that author team do to make you be attracted to that article? That's what you've got to replicate. So what you do, okay, the main core of the article, that's what it's all about. You start with the aspect, not at the end of the title, because humans skim down, and as the eyes can't track a whole page, they'll track half a page. So therefore, it has to be in the first few words what the main part is. So it's the main issue, the art paper, you begin with that, so the eye can find it. It has to be short as you can be, as accurate as you can be, and that's a difficulty, because to be short and accurate often are opposites. Often trainee, junior researchers, they go to a conference presenting a poster, and the title of the poster is 3 lines long. That's not how you do it. You've really got to work on this. It is practice. That is one thing. The more you do write, the easier you get at doing titles. No weird abbreviations. And again, your job is to hook the reader with what you have written in the article, but also be honest. You're not going to do something different. And it's actually sometimes you get some very interesting results. So many years ago, 20 odd years ago, I was literally looking into the holy grail of, is there a link between downloads and citations? There isn't, but then I was looking for these things, and then there was a highly downloaded paper in Feb's Letters at the time, that year, and that paper was from a Spanish group, and it was entitled, "Why Females Live Longer Than Males." Everyone wanted to look at that paper. That's all it was, very short and snappy title. When you go inside, look at it, the abstract, hormones, boring, move on. So it's hugely downloaded, not very well cited. But anyway, it's a top marks for a great title. So yes, again, make it as snappy as you can, as attractive as you can, just to get people to go in to look at your abstract. To find you, they've got to use keywords. And the keywords, what keywords are you going to use? How do you find things? You put keywords in, you go into your favorite search engine, and you find the keywords. And that finds you the articles. And then you think, oh, okay, neat, I know that, don't know that. And that's its job. So you find what you think are appropriate keywords, you put it into your favorite search engine, and see if what it finds is basically what you're about to write, or what you are writing. If it does, great, good keywords. If you find there's far, far more, then you've got too much noise to signal, so therefore you need to perhaps fine-tune the keywords a bit. If you find your keywords give you 8 hits in PubMed, you're definitely a bit too narrow. No one's going to find you ever, ever, ever. And so from that point of view, just play around with the keywords. You want to have 100 or 200 papers published in the last few years, and that would be a nice sort of number of what actually you need to be in that group, that audience. It's also useful to see what these keywords, see what they do. Because those keywords in your favorite search engine give you a bunch of articles which you didn't know about. Look at them, read them. Are any of them of value? Are you going to be citing any of those? Are you going to be somehow including that in your description of in your writing the manuscript? Because when you send your article in to a journal, it'll go to referees. They will look at your keywords, use their favorite search engine, probably the same as yours, and find out what articles are there and see if you've cited the most appropriate ones. And if you haven't, they're thinking, what's going on here? Why did these authors not cite these special papers? Is it because they're lazy, or is there something wrong with the paper, or what's going on here? So always use your keywords as a sanity check to make sure you haven't missed any references. Let's face it, you come across articles almost by accident. Someone tells you about something, or you find something by mistake, and then you find it. This is you structurally looking for things. So it fills in the gaps in a Swiss cheese, basically. So it's always very useful to actually broaden your horizons a little bit, to see what's there, and to see if there's any valuable references to help you in your research and to add them to your paper. Because if you don't, the referees will be upset with you and mention it in their comments. The abstract, of course, is where you are going to be sharing what you did and what you found in a short way with the audience, the reader. So they get the title, they read the abstract, and then if all's good, they go on into the article. Sometimes you've seen a great title, look at the abstract and think, not for me. Well, it's done its job. It's stopped that reader wasting 20 minutes of her life, and so therefore she goes somewhere else. This is good. And it tells the readers what you did, what you found. Some journals are very, very tough. They say 50 words, but in general it's a paragraph. If they let you do highlight bullet points too, great. Highlight bullet points is just literally to sum up, as well as the text of the abstract, what's in your article. If you can't think of some bullet points of the benefits of what's in your article, why have you written it? Huh? So you really make sure that the bullet points are useful. If you're given the opportunity of a graphical abstract, even better, because we think in pictures. So either create a new image as for the abstract, or alternatively use one of the most appropriate figures from your paper as in the graphical abstract as a way to get your readers engaged with your article. Say it's an advert. It can be seen by everyone without having to go onto campus or whatever to go into the IP address of the library. The thing about abstracts also is that the referee is not given the full paper to evaluate until they agree they're going to evaluate it. They're given the title, the abstract, and depending on the journal, they're also giving the authors and the affiliations as well. And based on that, the referees have to decide do they want to review the paper, yes or no. So the abstracts has to be strong, clear, because also you're trying to attract referees to be interested in the work such that they will review it for you. So again, do not think of it as an abstract as something just sling together. It's actually a very, very important aspect of the paper, often overlooked. The title and abstract are the bits which can be seen by everyone, so do spend some time on these. This happens to be chemistry. Here's what we did, here's what we found, basically. So the abstract's job is just very clear. It's a précis of what your paper's all about. Of course, using the fish style, the next thing is the introduction. A few, perhaps, seminal papers, a couple of recent reviews, a few words describing that, explains where your work sits in that particular part of the research ecosystem. So that's what you're not writing a history lesson. You're just saying, okay, here is what's happening out there, and here's what we're doing. So, is there a problem? Are there solutions? Are the solutions good enough? Have you got something better? Is there a better method? Even limitations maybe in what you're doing. What do you want to achieve? What you want to achieve, introduction, wall style, was written after you've written the discussion and conclusion, remember. So you should be able to make sure what you hope to achieve in your introduction text matches your conclusion and your discussion. If not, you've got a logic problem. So it's always the idea just to paint that picture of where the field is and where your work fits into that. It's a funnel idea. So it's not a history lesson, it's brief. You're not going to put the introduction and so on in all different places. It's simple, this sequence going through. Now, here's the problem, here's what we did, here's what we found, and so on. You're not going to say how amazing it is, first time, great, amazing, fantastic, Nobel Prize material, no. And only relevant references. References is simple. The job of references is twofold. One is to let a reader who doesn't understand a particular point go deeper. So nowadays it's all hypertext linked. So they go, oh, not sure about that. Click, click. They read the abstract or the whole article, come back, keep on going. So that's the job of the abstract, it's to brief the reader who doesn't know that aspect. And the second job of the abstract is to validate why you've done the work. Basically, these researchers have done the work, we've read their work and done some more work on top of that. That's our validation. That's all you need that's the only validation you need. Standing on the shoulders of the giants who came before you. The next aspect, fish style, is the method of the experimentation. Now, A referee would love to look over your shoulder as you're doing the work to make sure it's done properly. They can't do that, so they rely on your description of the method, if that's good or not. That's the challenge they have. So what they do is that they think, okay, are the details clear enough? Now, some journals are not very nice. They say you've got this much space and you need this much, in which case you use this much for a short method. The last line says, and the full method protocol can be found in the supplementary file. That makes sure that your work can be replicated. If there are some things that are standard, like you purified the protein by the Lowry method, just mention that. There's no need to explain the whole process if it's a standard process. Always use the various equipment manufacturers, what sort of machine they have, if it's a certain chemical, what purity it is. Some journals even encourage you to use the catalogue numbers of the chemicals, make it easier for the replication to happen. If you ask someone like Sigma Aldrich what phone calls they get from customers, customers say, I've read an article and it says you supply this, I want it. And they say, well, what's the purity? I don't know. So it's up to the authors, if they know that, say, 98% purity does not work, but 99.9% purity does work, to mention that in the method description, just to make it easier for the reader to replicate the work. Think of the reader as a friend in another part of the world. You want them to repeat your work. How are they going to do that? Make sure you do it very clearly and carefully. Control experiments should be in there, of course, as we mentioned. You're not going to discuss any of this. That's further down the manuscript, this logical line. You're writing in the past tense. And so if the referee thinks your method looks very sloppy and not very good, then any results you're sharing are suspect, any conclusions irrelevant. If your method looks like it's well written and it can actually be easily replicated, any results you're sharing have value and any conclusions have value as well. So always be careful about how to describe your methodology. Now, with the results, this is something that young researchers often get wrong. They want to somehow justify the paper by saying, well, we've done all these various things, these are all the results, so here they are, everything. Far too much. The job of the researcher is to decide the minimum amount of information to share with the reader. Not to hide things, but just to make it easier for the reader. What are you going to share? So the skill of a writer, an author, this is a picture of an iceberg. Imagine this is what you're going to be sharing with the reader. That's what you're not going to be sharing with the reader. How do you get that balance right? You've got to focus on the main findings, not everything, just things that tell a story. Once you've decided what those main findings are, make sure the methods you described in the methods section link to those particular results. It's a bit silly if you've got 4 or 5 methods and you're describing them and they're about stuff down here. You've actually got to be describing the methods you use to get the things up there. If you find things that are different to what's expected, oops, we must have made a mistake, or delete that. No, it's the wrong way. Oh, that's interesting. Is this an artifact? So you check it and double check it, perhaps even triple check it, to make sure it's not an artifact. Good, you know it's now real, it's scientific data, which you've proved different to other people in the past. Good, you hang on to that. Make sure your stats are appropriate. If you're using the wrong stats package, you can make a mockery out of your results. So make sure, if you're not sure, there's always someone on campus who will understand what sort of stats program you should use to analyze your results. If you can, use lots of figures and short, snappy tables. Not huge, snappy tables, which 8 people in the world will love. That's great for the supplementary files, but short, snappy tables with figures. Why? We think in figures. If you have a figure with a very comprehensive figure legend, that stands on its own. There's no need to write about that in text. There's less writing for you to do, which is good. There's less reading for the reader to do, good. And the reader absorbs the more information because it's in a visual form, so it's a win-win, basically. But make sure your figure legend is detailed enough. If you are finding you're actually writing next to the figure more information, your figure legend wasn't enough. So just get the balance right. Sometimes the figure legend is 6, 7 lines, but it's done its job. No, it doesn't need to be written about in the body text of the article. And of course, when you are doing your results and you're laying it out visually, 3D plot or 2D plot, if you are bilingual, trilingual, make sure that the axis text is in the language it should be, English in this case. If you're doing a photograph, you must have a scale marker in the corner. Again, no other language tucked in there. If you're going to have something like, here's a, that happens to be pharmacology here. It says drug crystals. And it could be that you're trying to explain to the reader that that drug crystals can be found in some matrix. And you could be woken up at 3 in the morning, shown these and say, oh yes, drug crystals. Perhaps the reader is not so fortunate and skilled as you. So therefore, you could describe it in the figure legend, but also better to have a couple of arrows saying drug crystals, just to be very clear to the reader what you're getting at, which is fine. Here, of course, if you're using color in graphs, think about the needs of the reader. If you can see this, you just about see the difference or not. One is dark blue, one is pink, dark pink. If you print that out in black and white, it looks the same color exactly. This was chosen with care. So you should do triangles and squares or something, just so the reader is not forced to go to a color printer. Think of the needs of the reader here. Again, just simple. And color is free in online normally. Well, there are a few some society journals charge for color online. I think it's criminal because there's no extra processing costs involved. But anyway, in general, it's free to be online. So use color sparingly just to make the better appearance. You don't want to have all fancy flashing and whatever, but you want to be simple and clear just to make an easier picture. Remember, of course, that 10% of males are red-green colorblind. So another factor, by the way. So you don't want to have red-green here. You want 2 other colors. Because 10% won't get it. Discussion, what do the results mean? You've chosen results carefully, you're going to discuss them, and each result you've chosen to share with the audience you're going to discuss. If you have, say, 6 results, discuss 6 of those. If you have 6 results, you discuss 4 of them, there's 2 missing. You either cut 2 out or discuss 2 more. They have to match exactly. They all should be interpreted. Of course, do the results relate to the original question? I hope so, because you wrote the introductory section after you wrote the discussion, remember? So they should match. Have other people found things differently? If you found something different, you're very clear. Other researchers have found other results, reference. However, we're sure it's not an artifact, and here's what we think is going on. So you're actually very clear. It could be that your introduction, your concept of what's going on is wrong. But other people will find your paper, they'll reproduce the work, they'll have a different interpretation. But you're the first people in the world who found this, so they can actually at least can replicate that work and then come up with their interpretation, and they will cite you for having found that particular property in the first place. Are there limitations? Maybe there are. Maybe your cell line's been compromised. Maybe the place where you took all these samples is now flooded or destroyed in an earthquake or something, whatever. So if there are limitations, mention it, or it could be that particular piece of equipment is no longer made, whatever. Just mention it. Be as transparent as you can be. And of course, that whole discussion process should lead on to a conclusion. And you've got to make sure that there's no new terms or ideas come in here, and also make sure that the statements don't go beyond what the results say. So if you've got results doing this, the discussion should not be that. I said earlier, we recognize we have to write the papers up to finish the experiment, to get the credit, but we want to move on to something else. So we're writing up the paper, we move on to something else. That's much more fun, much more interesting, but that's still got to be done and finished off. But sometimes you can get leakage of what you're doing here somehow creeps into the paper you're writing on. That's a new concept, a new term, a new idea has crept in from the work you're doing. So you've got to be very careful about that, because that's your next paper, not this paper. Conclusions, of course, global conclusions, specific conclusions, applications, uses. Future experiments, great. Future experiments is useful to say, well, actually, here's what still needs to be done. And we're doing this one already. That's the next one you're working on. And of course, that's great. That tells the reader, oh good, they're working on that, fine. So I can wait till when they publish. It could be, of course, that people will say, oh, they're working on that already. Shucks. Too late. It's boxed off now. Okay. Potential competitors. Or it could be people say that you're actually working on this already and think, oh, that's neat. I'll contact them, see if we can actually work with them to collaborate. So it's always good, if you are working on something, to mention it there. Also, other people can say, well, they're working on this, so it's off ground, but they're not, so I'll think about one of those. So that's the sort of thing you're doing. You're helping the field move forward, and what you're doing, by you deciding what future experiments are needed, you are shaping the field. You're pointing in the direction you want the field to go. That's the subtlety that you, as a researcher, can have on your whole environment, of your peers, suggesting where the research should go. So it's always a useful thing to do. It's your impact on steering the field in these conclusions, these future experiment suggestions. You're not going to summarize the paper. That's, of course, the abstract's job. And you're not going to say how wonderful it is. That's the people who cite you can say how wonderful it is, not you. That's how it works. Then, of course, you have references that come after that. And most people are using a reference management system. It's an idea. If not, I suggest you start using one. It's your responsibility, not the journals or the editors, to get the references right. If you get it wrong reference, then only about a third of the journals in the world use reference management software checking. So we do, for example. So if we see a reference which actually doesn't mesh, we'll say to the author, this doesn't look like it's the right reference. Can you please check on this? But in fact, many publishing houses don't do this, which means that if those journals are covered by, say, a Clarivate for impact factor, that author will not get noticed, and so therefore they will lose a citation. It's always not fair on the author. They haven't got a citation because you didn't do the text right. And so there are different sorts of these reference management software. Mendeley's a bit big there. We're biased. I say we liked it, we bought it, we give it away for free. But typically it's EndNote and Ref Manager. They used to be competing till they were bought by the same company. And a comparison of them is a Wikipedia link here. You can go and look and compare the various systems. It's a useful thing about any reference management system. Say you have journal A, and they've got a certain layout style, and then you're unsuccessful, and you've got to go to journal B, and you've got a different reference style. You can just download that list of references in a different style straight away, the click of a mouse, as opposed to rewriting them all. So that's the usefulness about having them all stored in a central system. It will download them in the correct format for the journal you're then choosing to send into. Supplementary material, there's things which is at the end of the article, hidden away. In the old days of print, it was never printed, but now things aren't printed very much, but it's there. It is, some things are specific. So if you've got, say, a long method protocol which wouldn't fit in the space allowed, you can put it there. If you've got, say, various figures, and one figure is the one you're choosing to put in the article, the other ones will still be there. Say the Journal of Cell Biology says, if you make any changes to the color balance of articles, you should really put the original unchanged article figure in a supplementary file so all the readers can see what you started from. It's all various reasons to use supplementary files, supplementary data. The one problem currently with supplementary material, supplementary files, they're not easy to find by data mining software. That's the sort of, we know that. So because of that, by putting your data in something like Mendeley data and then getting this DOI, it's easier to find because that's searchable by the data mining tools and also on data in brief or something similar. The idea being putting it in the supplementary material is fine, but it's better if it goes somewhere else. Now, do referees look at supplementary data? Some do, some don't. You have to assume they do. So everything in there has to relate to the article, not to be a place you dumped some data to say you've published it, basically. Then you've got to think about the covering letter, the cover letter. Should you do a cover letter? Is it worth it? Yeah, it is. It's like if you're applying for a job, you just send in your CV, Or do you send in a CV and a covering letter? Obvious. Do editors read the cover letter? 9 times out of 10 they do. Not everyone, but 9 times out of 10 they do. The job of an editor is very simple. 2 jobs, actually. One is to filter the junk, do desk rejects, and secondly, to look for good material. So you're going to say to the editor, this is good material, basically. So you're trying to hook the editor on your side. What makes your manuscript special to the journal? Is it perhaps that this journal has had several articles saying, we couldn't do this, we couldn't do that, and you found a new method? Great. Or is it this is the place everyone puts their particular papers in this particular ecosystem? That's the place to be? Fine, whatever. All those different reasons why you should go to that journal. And of course, it's 1 page maximum. That's the challenge. All authors approve. Here's what's important to the field and to your journal, and here's some potential reviewers. Now, if, for example, you don't have to put reviewer suggestions here, they're somewhere else in the journal system, where when you're starting to submit, it says, OK, list potential reviewers. You can use this place for potential non-reviewers. What's a non-reviewer? Someone who has a conflict of interest. Now, in theory, when a person is asked to review a paper, if it's a bit too close to their field of research, where they feel it might be a conflict of interest, they should decline, and so that way they don't get to see the paper. But at the same time, you can be a bit proactive and make sure this actually does happen. So it could be you can say to the editor, hey, editor, I'd rather you didn't send this paper to this group in Melbourne, Australia, and this group in Toronto, because they're working in the same field as me, and I would like them to see this scientific paper after it's been published, not before. Now, most times, a journal editor will listen to your suggestion and go with that. If you give a list of, say, 40 or 50 people you do not want to see this particular article before publication, they'll be so suspicious, they'll send it to a couple of those to find out why. Fair enough. Treat an editor with respect, they'll treat you with respect. Try and fool them, they will not be happy. If you're asked to suggest potential reviewers, some journals it's compulsory. Unless you suggest reviewers, you can't move on in the submission system. Always use their institutional email addresses, and that's important, not just their Gmail or Hotmail or 163.com. Who would you want to be a good reviewer? Whose values do you respect? Who, perhaps, someone you've seen recently or someone you've read recently, who would you like to comment on your paper? Do you need to ask their permission to list them on the potential reviewers? Not at all. It's anonymous peer review. Just list their names. Are they going to be asked? Maybe. Some editors will look at your suggestions and say, oh yes, that's a good person, I forgot that one. Yeah, good. They'll actually use your list as a sort of almost a memory jog. They might have their own ideas, and they're going to send it to those people, but they look at who you suggested to see if you know who the right people are. They think, I know I'm going to send it to these people, but yeah, that's not bad. That's not, yeah, okay. The authors know what they're doing. They've just evaluated you as people, not just your paper. And if people they've asked said, no, we're too busy, they'll come back to your suggestions and say, oh, maybe I'll try those. Well, they first check them out in Scopus or something similar to see that they're good people, high H index, and appropriate for the field. We have here, reviewers should represent at least 2 regions of the world. That's because there's 2 regions of the world who tend to focus just on their own area. So often authors from China will list reviewers from China, and authors from the US will list reviewers in the US. The rest of the world actually spreads out quite well. So that's why we mentioned that there. And of course, they shouldn't be your supervisor, they shouldn't be your close friends. In some guides to authors, they say they shouldn't be people you've worked with in the last 3 years. They shouldn't be your uncle in Canada. They should be people whose opinions you respect. And it could be that you can look at your introductory paragraph, see a few references here, and they are good people. So you can list those. It could be that those people are too busy, but their postdoc might have time. So that's the way it works. And of course, if you are going to suggest people, perhaps who have published a while back, just check out to make sure they're still alive. If they've passed on, you should know, it's your field. The editor will know. So always make sure that they're still around. You know, it's more than likely, if it's just recently at a conference or something, it's fine. But if it's a seminal paper from 10 years ago, maybe not. Maybe they have passed on. In which case, just check it out. Make sure they're still around. It's happened, I'm afraid. It's happened more than once. So anyway, you're doing your various process, you and your co-authors are writing various bits and pieces, putting it all together, you actually think you're getting pretty good. And then you write it, rewriting it, you put it aside for a few days, you polish it some more, and then you ask people who are not linked to the article, perhaps superior, supervisor, colleague, other people, other places, what they think about it. Think of it as like a pre-peer review. Then they give their suggestions, which you might not like, you might like. Then between you, the co-authors decide, okay, here's the suggestions, which ones are we going to do, which ones are we not going to do, who's going to make these changes, you make the changes. You polish up the paper so it's as best as it can be. Make sure all the co-authors agree this version. Then you submit it. When you submit it, it goes to the editor who says, okay, are the basic requirements met? There's a little filter here because we actually make sure that everything's there, like the conflict of interest statement, the right number of figures, and so on. If this is outside of scope, it's a quick out of scope reject. If the English is so bad, reject. And so if it looks like it might be possible, okay, who's the best people in the world I can send it to? They decide, okay, these two people, and they send it to these two people, and one might say yes, and one might say nothing and time out after a week or so, or might say, no, sorry, I'm too busy. And eventually, two people are found to say yes. They're given between 7 and 14 days to come back with their comments. Some journals give them 3 days. It's a very, very fast journal. And then they come back with their recommendations. Referees do not decide, they recommend either accept, reject, revise. Then the editor's job is to make a decision to reject, accept as is, or revise. Simple as that. If it's accepted as is, it's very rare, very, very rare. If you had a paper accepted as is, the average in life sciences is 1 in 200. That's why I asked everyone done 200 papers. So if you've had a paper accepted as is, and you publish less than 200 papers, you're ahead of the curve. Good for you. Of course, the next paper you send in, which might get rejected, is a bit rather sad. If you get rejected, it happens to everyone, even Nobel laureates. You're allowed to get angry for 5 minutes or so. That's it. You and the co-authors get together, either by Skype or in person, all agree the editor's an idiot, referees are stupid, blah, 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 and move on. Okay. It happens to everyone. You then start to look carefully at what they've said. Also, read carefully what they say. Sometimes you stop reading when you see the word reject, and you go, It might say, you're rejected, but fix all these things, and we'd love to see a new version. That's called a reject with hope letter. We do have that version in our submission systems. So always read what it says, get your co-authors to read what it says, all agree it says what it says, and then move on from there. If they say basically, your paper's rejected, go away and never come back. This is pretty clear. Okay, go away, never come back. But what have they said? What comments have they said to improve your paper? Okay, that's the important thing. Then you look at this between you, say, okay, fair enough, they got a point. Who's going to do what? So which author is going to do which bit of this revision? Then you all decide this, you then decide a timetable to revise, and it's not long normally, and then you do the revision of the paper. If it's an extra experiment, you work out, do you want to do this or not? If you do, you decide who's going to do this. If you can't do it yourself, you've got someone else to come on board, do the experiment, then you add them as a co-author. And then it's the point, you think, okay, I've improved all the various bits they've asked. They don't want it back, they said that, so I'll go on to Journal B. Remember we had Journal A, B, C, D, E? Journal B. You read the guide to authors of Journal B, you change around the layout of the article to match Journal B's guide to authors, you download the reference style to its Journal B reference style now, and you change the covering letter. The last thing Journal B editor wants to get is a covering letter. Dear Journal editor, we're sending it this because Journal A is the best place to publish this work. And they hate each other, Journal A and Journal B editors. They compete with each other. The last thing they want is to know that they are the substitute, the Journal B, or perhaps even the Journal D, they don't know. But you don't want them to know this, and so basically you want them to be not antagonistic to you. So make sure, the trick is on the hard drive, you label that file Journal A, or Journal whatever, covering letter. So when you start to upload it to the next journal, you realize just in time, stop, change it, re-upload. Good trick. It happens too often, I can assure you. Far too often. We have these horror stories from editors who really feel, well, undervalued, should we say. It's a polite way of phrasing it. If they've said, hey, it's a revision, then what happens is if it's a minor revision, it goes back to the editor, who says, okay, have they fixed all the things? If it's a major revision, it goes back to the reviewers, and all your concerns have been met. So for a major revision, the referees have concerns, they hope you can fix it, they're not sure you can. For a minor revision, they think you can fix it if you go through all the points and do it. It's not a guarantee, but it's pretty close. When you have decided to do all this revision, then you see what they've asked you to do. But some journals ask you to color code it, some ask you to use line numbers. What you must not do is just say, thank you for all the points, we accept them all, we've done it, here it is. That's useless because the editor does not know what you've done. They want to know line by line, point by point. So you do cut and paste, referee 1, referee 2, A, B, C, D, E, and then you literally, this is the point, it makes sense, yes, we agree entirely, we change the text, here's what you put now. So by doing through that, it's point by point, that's a way to reassure the editor you've taken account of all the various points mentioned by the reviewers and you've changed the manuscript appropriately. When you do change the text, make sure it's polished. If you just do quick insert of text without polishing the whole lot, it looks very scrappy. Also, the editors will say, this is not a good revision because you haven't polished the text. If they're polite, they'll say, try again. If they're not polite, they'll just toss it out. If you don't like what a particular referee says about a particular topic because you think you're right and they're wrong, you, all co-authors, have to agree this, not just one author, all co-authors, then what happens is you then say, okay, this is rebuttal time. So you then send your paper in, saying we've done all these changes, we haven't changed this one because we have rebuttal, we think that this should not be changed because this reason. Perhaps that referee has not seen this particular paper, and we think that our paper, that text should stay as it is. Rebuttal. Be very polite, because what happens is that text, the editor will look at it and say either, yes, I'll accept that, so the record of science stays what you want it to be, or they'll say, no, we don't. If they say, yes, it is, they'll send that, your text, to the actual referee, saying, hey, referee, all the points are okay, except there's a rebuttal on one of your points. Here it is. So what happens is that's the point. Anonymous peer review, you didn't know them, they know you, be polite to them. In their spare time, they did this for you. So just it'll take your time. You must make sure everything's polished, make sure that all of the co-authors agree the revised version. If you revise it on your own without including all the co-authors, because one's on vacation or something, no. You've got to make sure everyone has seen this and agrees it, because if someone disagrees with what you've done, they can insist you withdraw the paper, change it till they agree, all of you, and then re-upload it again. So from that point of view, always make sure everyone has done it right. And then you're basically one of the 30% with luck, accepted, not 70% rejected. You've got to be consistent, check and double check your work, clear logical story, use referee comments. And that basically means, it's not rocket science, but it's just common sense. But often we just don't think about it. It's a structural way we've been looking at here. Here's a nice mnemonic I'll let you read through, because you can read through faster than I can talk. Be ethical, basically, yes. Open access, a few short, very slides on open access. There's so much information on open access. There's so much up-to-date open access information out there. But basically, you've got gold open access, whereby an article is paid for by the author, the funding body, or university, so the reader pays nothing. So it's not a subscription, it's an open access article. They get more downloads. At the moment, they seem to be getting about the same number of citations. We're not sure if that's going to be changing in the future. Green open access is called open archiving, whereby after the so-called the period of embargo, then you can then publish your accepted manuscript you sent in, not the final version with all the extra information in there, but say the accepted author manuscript with the reviewer's comments can be posted on your website of your university or your university repository or whatever. And that's a free process. People publish in open access for different reasons, sometimes because the field expects it. So genetics, cell biology expects that most of the work will come open access. Some areas like economics, no one's interested. It's all subscription. Sometimes it's a funding body mandate. The funding body insists this happens, which is fine. If you're publishing gold open access, of course, the same with any other journal. Find the right journal. Make sure it's in the directory of open access journals, DOAJ. See what the funding body and your institute wants. This is a changing field all the time. Make sure you use the right license, different licenses, and then get it out there and then use the information appropriately. As an author of an open access journal, you retain the copyright, you can send it anywhere in the world. Promotion, you can use the services that the publisher provides. For example, in Science Direct and so on, we actually do marketing all the various articles and the like. But also you can draw attention to these yourself. And the Researcher Academy has a whole bunch of resources on this. And here, there's a few links which you'll get as soon as you see the slides, which you go into and then find these information.